Welcome to episode 9 of the Java Basics series. In this video, we'll be learning how Java classes can inherit from one another and how one class can act as an instance of another class. So to understand why this concept called inheritance is important, let's first imagine a scenario where we're constructing a racing game with two different vehicles, a car and a bicycle. And so both of them have a brand, a speed at which they move at, and a method which allows them to move. So with our current knowledge, what we'd probably do when writing the Java code for implementing this is writing separate brand, speed, and move methods in both of the classes. And so that means it would become kind of redundant since we're just repeating ourselves unnecessarily. So in order to solve this, we could actually create a parent class called vehicle, and then car and bicycle are another set of two classes that inherit from vehicle. And we called those classes which inherit those traits child classes. So we can put the brand, the speed, and the move method inside the vehicle class, and then the car and bicycle classes will automatically get those same properties and methods, but we can also add on to each to the individual car and bicycle classes with their own properties and methods. So car and bicycle are basically just vehicles, but with more data and behavior that we can control. So now that we know how to implement this solution, let's actually get started coding. So firstly, we probably want to start with the parent class vehicle first. That'll include all the base properties, brand, speed, and the move method. Because then we can add on the child classes, which will inherit from it. So we can create a new class called vehicle. And then firstly, we can define all the properties, all the fields of the vehicle class. So firstly, we can add a string for the brand name, and then a double for the speed of the vehicle, because speeds can also be decimal values. And then we should probably create a constructor as well. So we can say public vehicle, and then we can provide the brand and speed in the constructor, and then we can assign it to the vehicle object. So we can set the brand to whatever is provided, and same thing with the speed. And then now we can provide the move method. So we could say public void move, because this method won't return anything for right now. We'll just print out a message, maybe saying this vehicle is now moving. So now we can actually add some modifiers here to the brand and the speed. So what we want to do is make these as inaccessible as possible, but one key thing that we want to do is allow the child classes to access these branded speed fields as well. So the strongest way to protect these values while also letting child classes access them is by adding protected to the end of these, to the start of these, rather. So protected doesn't let just any random Java file access them, but it does allow subclasses or classes that inherit from vehicle to access the brand and speed. So we're able to use them in new methods that only apply to a single vehicle or for overriding existing methods, which we'll look into later. So now we're all finished with the parent class, so we can create our first child class called car. So we can start with our car here. And so the way we can actually make car inherit from vehicle is by going to the top line here, and then after car saying extends vehicle. And then now this will make it so that it has the brand and speed properties accessible, and it has the move method already. So we don't have to implement those again in the car class. And then you can see there's an error here. It's saying implicit superconstructor vehicle is undefined. So we have to define our own constructor for the car. So you can just create a similar looking constructor here, providing the brand and the speed. And then what we actually want to do is provide the vehicle with the brand and the speed. So that way it can automatically run these, whatever we have in the vehicle constructor. And so the way that we do that is by using the super keyword here as a function. And so this super keyword allows us to call the parent constructor the vehicle constructor to automatically assign the brand and speed to the car, to make both constructors have the same behavior. So we can supply both the brand and the speed to the super constructor. And now if we were to create a car, we could create it in the same way as a vehicle. So now a car is basically the exact same as a vehicle because it's created in the exact same way and it has all the same properties and methods. But what if we wanted to add extra information and behavior about the car that would make it unique? Well, we could add a new property here that's specific to the car, that's unique to it, because it's not present in a normal vehicle, only in a car is it present. And so we could call this new unique property or field wheels, and then set it to 4 because a car has 4 wheels. So here, as you can see, we're defining a custom property for the car that makes it unique compared to just using the vehicle class that's already there. So now there's a reason why car actually exists. It's not the exact same thing as a vehicle anymore. So we could do the same thing with a method as well. We could create another method here, and this method would be just for cars. It wouldn't be inside of the vehicle class. So now we know how to create child classes from parent classes and then add on to them with our own customizations. But what if we want to actually change the behavior of a child class? So for example, maybe we wanted the move method to do something different in a car. So we can do that making use of a concept called method overriding. So method overriding involves creating a new definition for a method with the exact same name inside of a child class. And so if we wanted to override the move method, for instance, we could create a new definition for it. And then instead of printing just this vehicle is now moving, we could print this car is now moving at, and then we could print out the speed of the car here. And so we can just assume that the speed is in miles per hour. So that's what we can print out in the move method. And then finally, to tell Java that this is actually an overridden method, we have to go to the top of the method definition here, one line above where public is, and then we can say at override. And so at override indicates that a method declaration overrides a method inside of the parent class. So this is just to tell Java that we're actually overriding the method, because if we didn't have this here, then it might be slightly confusing to have multiple move methods and not knowing which one is actually overriding the other. So overriding methods is useful because different instances of different types of objects, like different types of vehicles, might move in slightly different ways. So for example, a car might move by burning gas, while you pedal to move a bicycle. So now you can more clearly see a motive for overriding a method through this other bicycle class, which also is a vehicle. So in the bicycle's move method, it tells us that this bicycle is pedaling to move, while a car does not do that. It burns fuel. So vehicles that work differently, like cars and bicycles, have different behavior. So that's why we need to override method. This customization of behavior that method overriding allows us to do also enables us to use a concept called polymorphism. So polymorphism is a Greek word that means many forms, and it allows different objects to be treated as the same general type, but behave in a unique way. So, for example, both cars and bicycles are vehicles. And that means if we create an array of vehicles, we can store both cars and bicycles in there, and then we can iterate through them, through all the cars and bicycles, and move each of them. So we don't need separate cars and bicycle arrays. We can just lump them all into a single array consisting of vehicles. So let's create a new class for our main method to actually show off polymorphism in action. So our main method here, and then we can now create a vehicle array and then we can just call it the garage because it has all of the mobile vehicles inside of it. And so now we can initialize the garage with a new car, and then we can just say for the brand it's a Tesla, and then the speed it can be 60 miles per hour. And then we can also include a bicycle in there, so a new bicycle, and then the brand we can say it's a hero bike, and then the speed it can be around 3 miles per hour, way slower than the car. So now we can create a for loop, a for each loop. And so it automatically detects that we have a garage vehicle array. And so it automatically takes out, it iterates through each vehicle inside of it. And so now every vehicle we know for a fact has a move method. So we can just call vehicle.move. So now we can run the Java code. And then firstly, you can see this car is now moving at 60 miles per hour. So that's the move message for the car. And then this bicycle is now pedaling. That's the message for the bicycle. So now you can see, even though cars and bicycles have different behavior, they still have the same method name because they're both vehicles, which allows us to utilize a method shared by both of them and store both of them inside of a single vehicle array with the parent class as the data type for the array. Because both cars and bicycles are vehicles, it allows us to use this polymorphism concept. So now let's cap off this episode with a final challenge that summarizes everything we've learned. So for this challenge, what you want to do is similar to what we did in this episode. So firstly, you want to create a parent class called animal with a make sound method that will override into child classes or subclasses called dog and cat. And we want to override the make sound method so that the dog barks and the cat meows. And then finally, in the main method, you want to create an array list of animals with both dogs and cats and have them all make a sound by iterating through all the animals or pets with a loop. Thank you very much for watching. Hope you enjoyed. If you did, make sure to like and subscribe. And make sure to look out for episode 10, the final episode of the series, where we'll be going over how to fix errors in our Java code.